Today, I'm going to walk you through Federated Wireless's Automated Frequency Coordinator, or AFC, for 6 GHz standard power unlicensed operation. I'll explain what the AFC is, how it works, and what it enables. I'll also walk through how the system operates in practice and close with key benefits from a regulatory perspective. Before we get into the system itself, I'd like to provide a brief introduction to Federated Wireless. Federated Wireless is a leader in automated spectrum management with more than a decade of experience designing and operating large-scale shared spectrum systems. Today, our platforms manage hundreds of thousands of devices in real time, supporting commercial deployments across mobile, fixed wireless, enterprise, and government use cases, while maintaining strict protection for incumbent users. That operational experience, both technical and regulatory, directly informs the AFC system we'll walk through today. We'll begin with what the AFC is and why it matters. Then we'll walk through how it operates. From there, we'll move into a system demonstration. And finally, we'll step back and highlight key regulatory benefits and considerations. At its core, the AFC is a cloud-based coordination system that enables standard power unlicensed devices to operate at the highest permissible power levels in the 6 GHz band, while ensuring that incumbent users are fully protected from harmful interference. While outdoor or high-power Wi-Fi is a primary use case, this framework is broader than that. It supports a range of high-power outdoor and fixed deployments, including fixed wireless access and private network applications. So this is not simply a Wi-Fi optimization tool. It is a general-purpose spectrum coordination platform. Importantly, this is not a theoretical concept. It is already certified, deployed, and operating at scale in real-world environments and across multiple international regulatory engagements. A consistent set of requirements has emerged: reliable incumbent data, standardized interfaces, clear protection methodologies, and a scalable certification framework. Those same principles are embedded directly into this system. The role of the AFC is straightforward, but critically important. It enables devices to transmit at the highest permissible power from a given location while ensuring that incumbent services are not impacted. To do this, the AFC combines detailed geospatial data, such as terrain, buildings, and clutter, with propagation modeling and incumbent system characteristics, including antenna patterns and receiver parameters. Using these inputs, the system determines the maximum permissible power for each channel at a given location. This is a highly precise, location-specific calculation. It reflects not just where a device is, but how signals propagate through the environment and interact with incumbent systems. The result is a system that maximizes spectrum utilization while maintaining strict protection requirements. Now let's walk through how the system operates. The interaction between a standard power device and the AFC follows a secure request-response model. Before deployment, the device establishes a trusted relationship with the AFC. This includes secure authentication, ensuring that only authorized devices can access the system. Once deployed, the device sends a spectrum inquiry request. This includes its geographic location, installation height, device identity, and location uncertainty. These inputs allow the AFC to precisely evaluate the device's operating environment. The AFC processes this request using a combination of pre-computed data and real-time validation. It evaluates nearby incumbents, applies propagation models, and determines the permissible operating parameters. The system then returns a response indicating which channels are available and the maximum permissible power for each. The device uses this information to configure its operation. Importantly, all of these interactions are logged. This creates a complete and traceable record of how each authorization decision was made, supporting compliance, oversight, and enforcement. Now let's look at how this appears in practice. Here you see a real-time view of the system. Devices, primarily access points, are displayed geographically along with incumbent systems. This provides immediate visibility into the operating environment. From an operator perspective, this supports planning and troubleshooting. But from a regulatory perspective, it provides something even more important: transparency. We can zoom into a specific area and examine individual devices. For a given device, we can see exactly how permissible power is allocated across channels. In most cases, devices operate at or near full permissible power. Where constraints exist, they are clearly shown and directly tied to specific incumbent systems. We can also visualize those incumbents. This allows us to understand exactly why certain constraints are applied. This is a key point. The system doesn't just provide an answer, it provides a transparent explanation of that answer. Now let's look at how this supports planning. Here we're using the Adaptive Network Planner. This allows us to query any location. We can simulate how a device would operate before deployment. By adjusting parameters like height or deployment type, we can see how permissible power and channel availability change. This is extremely valuable for optimizing deployments before equipment is even installed. Stepping back, it's worth highlighting what the system provides from a regulatory perspective. Transparency and consistency. The AFC provides a clear deterministic framework for device authorization. Enforcement and operational visibility. Because all decisions are logged, the system provides a complete audit trail. Flexibility and adaptability. The system is designed to evolve as new incumbents are added. Security and protection of sensitive information. Devices are uniquely authenticated, and sensitive data can be obfuscated. Taken together, these capabilities provide a system that is transparent, enforceable, adaptable, and secure. From a broader regulatory perspective, leveraging global standards, ensuring data quality, and enabling certification at scale are key. In closing, Federated Wireless brings deep expertise in both the technical and regulatory aspects of spectrum sharing. The AFC provides regulators with a powerful tool to manage spectrum dynamically. If you'd like to learn more, please contact Federated Wireless for additional information or to arrange a more in-depth workshop on the AFC.